Hello, and in this video we're going to be continuing our project for the solar panels. So in this video we're going to be doing some preparations for backup power to be supplied inside our house. And we're also going to be exploring how these solar panels and the battery have been performing in the 2 weeks since my last video. So this is our board. You can see here I've marked the outline for the changeover switch and the consumer unit, and now I'm preparing grommets for the consumer unit. So here it is, the consumer unit and the switch. This is what it looks like with the covers on. So as you can see, this switch, changeover switch, is absolutely huge. Well, time to pull this cable. Got a different cable reel because it's a much bigger loop, but yep, time to do this. I have to say, not a big fan of cable pulling. I never have enjoyed cable pulling, especially through the loft. Well, this cable is a different beast to the Ethernet cable. Much heavier, much less flexible, and not my favorite at all to pull, but it is coming. It'll take quite a few iterations to spool out cable, repeat the process. Yeah, the other thing I don't like about lofts is putting a foot wrong and ending up downstairs in a hurry. Right, let's get some more cable. So we've now got the cable pulled. We've got a conduit to add, and then it comes out here from that hole there, and then it's time for clipping all the way back to the entry point into the house. Okay, so this is our cable clipped in. Then we'll get those clipped in, four more clips I reckon. So now time to pay out the spool of cable and judge how much we actually need. One YouTuber said the most expensive cable in the world is that which is 10 centimeters too short. So here we are. I reckon before we commit, let's just go in here. Okay, that's plenty. Okay, let's feed it through. That's the cable chased into the duct almost. And you can see plenty. Okay, so cable stripped. And that's the cable in. Okay, so we have now terminated the supply to the backup loads in the house. Here on the line, here on the neutral, and here on the earth. So this is the switch connection to the consumer unit. So that connection is now mechanically complete from the shed. And as you can see with the earth, I reckon we should be able to get a third spade on that ground connection. Okay, so now it's time to do some continuity testing. So we're doing a continuity test between line and neutral. Okay, so we will just pop that on here. Then we will do that. And then we'll press the test button. 0.92 ohms. Okay, that's quite high. Okay, 0.38 ohms. That's much better. We'll now do R1 plus R2. Okay, so now it's time to turn on the shed consumer unit. Switch on the lights and the mains. Turn on the lights. Nice. Right, so now we will switch on this and then we will go inside. Okay, so First things first, measure voltage on these. Okay, excellent, 240 volts. Measure voltage down there. Nothing. Okay, so that is as expected. So now we will put this in. Okay, and then we'll switch this on. And then we'll repeat this test down here. Excellent. So we've got 240 volts. Before we do anything else, we'll turn it off, because there's no point having it on at this stage when we haven't got any circuits connected. Well, I have to say, I'm absolutely knackered. Terminating a cable on both ends on a bench takes about 10 to 20 minutes. But when you have to do it from one end of the house to the middle through the loft, have to nail it down, you have to pull the cables and so on, you realise once you finish that actually you're only about 30% complete. Terminating it and stripping those heavy cables really hard. So future self here with a different jumper. I want to talk about cable stripping, because this took a long time with 10mm twin and earth. So my usual tool of choice with smaller gauge cables is a cable stripper like this. But as you can see, 10mm twin and earth sheath doesn't fit in here. This is good up to 6mm twin and earth. So different method of stripping this. I've got this tool here. It's called the Knipex Ergo Pro tool. It's got a little end here for stripping things. What you do is, it's really designed for round cable, but you can grab the end of the twin and earth, which is round, grip tightly and pull towards, and you can open it up. But as I've discovered fairly recently, it penetrates a bit too far sometimes. And if you see here, you can see it's actually scored the insulation. So this is easy, but it's not going to, you're going to have to be careful with the pressure. So let's do another method. And the other method is with a utility knife, one of these. And my method was to score down the middle like so. And scoring down the middle is where the CPC is, circuit protective conductor. The thing is, though, is that you have to be very careful not to drift, and you've got to apply the right amount of pressure to actually split it. And it's quite a devil's job to open it up. And the thing is that if you make a mistake and you damage the insulation, you're going to have to pay out more cable. So one thing to say is that you should always have some spare slack in case you do make a mistake. My electrician has got cooker cable coiled up underneath here for that reason. Because if you run out of cable length, you're going to have to run a new cable, and that's going to be the most expensive cable you've ever paid for. Yeah, I found this really quite difficult. So you can score along here, you can score along the edge, and we'll score along here. And maybe I've scored just enough to start being able to strip it. So yeah, I can get the corners. So now that's split. And if you have paid your monies and you've gone for the cable which has got chalk in it, which most cable does, but sometimes you can get cable that doesn't have chalk in it, which is got a very high swear word coefficient when it comes to stripping the sheath off. Yeah, okay, so I think I've just got that, like so. There we go. That's how you strip the cable. Takes a little while to learn it, but using a knife around here and being careful not to nick into the insulation underneath is the best way of doing it. But yeah, it took a while. I was trying to strip right down the middle, and to be honest, you're kind of wasting your time with that. When you've got chalk, you can just cut around the circumference here and just pull it out, and it's much easier. But I would recommend you practice with a utility knife on a scrap bit of cable like this. So you can see inside my main consumer unit, we want to move 7 circuits across. And I think my personal journey with electrical work ends here. And you can see partially why. It's quite a mess. And electricians have got the craft needed to unpick this mess. And I'd be quite happy to do that myself, except for one thing. Even if this switch is off, those terminals there are still live. I do not have the authority to pull the D&O fuse and make this completely safe. So at this point, I am waiting for an electrician to tell me that they've got some time for me to deal with this. But in the meantime, the only thing I have to manage are these pesky earth leakage currents. So I've figured out that you can have the cooker off and or the computer bank array in my study off, and I won't get any RCD trips. So that's the only thing which conveys a little bit of urgency, but it is manageable for the time being. So these solar panels, and also the fence solar panels, they haven't been doing great. We're going to go into the studio and we're going to see exactly how much performance we've been getting out of them. So just as a comparison, my solar edge system on the 12th of February was producing about 2 kilowatts at its peak. You compare that to my SunSync system. At best, they were producing about 100. There was a small peak at 360 watts. So this demonstrates that for something which should potentially generate 2.5 kilowatts, we're not getting much out of our solar panel system on this particular date. Now, I will say on the last day of February, let's have a look at that. You can see we're getting much more consistent output here, about 1.4 kilowatts here at its peak. And we're just going to discuss why that is. So let's have a look and see what these panels are actually facing. They're facing all of this. And how much sky do you see? Not much. Probably only 10% of what they are seeing is sky. The rest of it is house, garden, and trees, none of which scatter light anywhere near as effectively as sky. And cloudy skies, even without sunshine directly, they create a lot more light for the solar panels on my rooftop than these solar panels will ever get. But it's more nuanced than that. So let's say, for example, you've got these 2 panels in the sun. They're rated at 485 watts. Realistically, you'll probably get 350 watts out of them each. Do we get 350 watts out of them each if these 2 panels are in the sun? No, we don't. We probably only get about 80 watts. When these are in the shade, there's an interesting effect which happens. These 2 panels will create about 40 volts of potential each. So that's 80 volts. Your maximum power is going to occur at 80 volts. And the bypass diodes on these are going to be triggered, which means the system voltage is only 80 volts. And when you bear in mind that the minimum voltage for the MPPTs to work, the maximum power point trackers, is only 125 volts, then you are forcing the maximum power point trackers to go to a voltage which is not optimal for the system. So you need a minimum number of solar panels in the sun in order for my system, my SunSync system, to actually produce a lot of power. But nonetheless, we have had 4 panels in the sun that will produce 160 volts at maximum power. And when you get that, we are starting to see around 1.5 kilowatts of power from this system. And that's really nice. But in the wintertime, this system is going to be performing badly. So has it been worth it? Well, in terms of experimentation, yes, it has. And it's something you need to pay attention to. This was clad in shiplap. And the cost of these panels per square meter compared to the cost of shiplap is starting to get similar. So then it raises the question, should you start cladding buildings in solar panels? This is a long-term question that we're going to be looking at. Heating of these panels is something that needs to be looked at, and what effect that has inside the shed. Does it turn this into a giant greenhouse? Those are open questions, and we're going to be finding that out over the course of the summer. So what about this battery? How has that been performing? Well, it's been absolutely stunning. For the last 2 weeks, we've had temperatures of -5 on one particular night, and this thing is still charging up. We're going to have a look at some numbers, and we're going to just see just how valuable this thing has been. So I want to talk about the coldest night to begin with. And the reason I want to talk about the coldest night is because when the temperature of the battery drops below freezing point, it cannot charge. It can continue to discharge down to a temperature, I think, of -15 degrees. So here you can see we got a minimum temperature on this particular night, minus 4.8 degrees. That was on the 19th, which I think is actually a one-day offset. But when I look at the actual battery temperature, you can see it was dropping from 3.6 degrees and it got to just above freezing point. So it was charging up at 2 a.m. in the morning quite happily. And one of the things I'll just say here is that for moderate frosts, the battery, so long as you keep it discharging up until the Octopus Intelligent Go period, it will probably stay above freezing point in moderate frosts. And -5 is a moderate frost. For harder frosts, you're probably going to need some additional insulation. But I want to show you what the effect of charging the battery is when it comes to heating the battery up. So this was the first night I was charging up the battery, and I charged it all the way up from 23% up to 79%. And the temperature does something very similar. It warms up. It warmed up all the way from 4.5 degrees to 14 degrees. And this is just internal resistance of the battery when it's taking a 6 kilowatt charge. So the battery is capable of just keeping itself warm enough on those cold nights. But you need to be mindful of the entry point into your Octopus Intelligent Go period. If your battery is off up until 11:30 and it's a really cold night outside, then chances are it's going to be below freezing. But if you keep discharging current up until 11:30 at night, keeping a heat pump running, for example, then your battery should stay warm enough to accept a charge, keep it warm enough above freezing point, and this will be fine. Now, one other thing I want to just talk about is the performance from Monday the 23rd of February until Friday. So we had 100% state of charge. We had a nice sunny day. And then on Tuesday, it was cloudy. We watched the state of charge continue to drop. Very little charging up going on. And then Wednesday was also a pretty poor day. It was just discharging throughout the whole day. And then Thursday, again, it was just continuing to discharge. And it was discharging into Friday. And Friday was a nice day. So it was charging up my Solar Edge battery first. But once it got to lunchtime, it was time for my SunSync battery. And the interesting point was that I did not have to charge this battery up at all at the end of February on overnight electricity. And it demonstrates that you can keep going self-sufficiently for multiple cloudy days at a time in late winter. So you can just imagine what it's going to be like for any other month between now and the end of October. But this thing it's been fantastic. The SunSync inverter, there are still issues with making sure this battery doesn't suck up the surplus power from my SolarEdge battery. I've got some automation ideas on that. As you can see, I've got a Raspberry Pi here, and I've got a serial interface, USB to RS485 serial interface. I'm going to be talking about that in another video. I still haven't worked out all the small details. I want to demonstrate something which is working rather than just simply demonstrate the whole problem-solving process. Now, here's the thing I'd like to just talk about, and that's cost. This thing cost £3,200. Compared to my SolarEdge battery, I paid £7,500 installed for my SolarEdge battery back in 2022. So this thing is less than half the cost. And bear in mind, back in those days, £6,500 was the price of the SolarEdge battery delivered. Now, the price is £3,700 delivered. So this thing is still £500 cheaper than my SolarEdge battery. And it's more than 3 times the energy. So you've got to ask the question, which system is better, SunSync plus Fogstar, or going for the SolarEdge ecosystem? And I'm going to have to say they've both got their pluses and minuses, and I think this is going to be worth another video, just talking about SolarEdge versus SunSync. There's a lot of nuance here, and there's things which need to be dissected a bit more. I've touched upon it briefly in terms of minimum MPPT voltage. We're going to go round the front to talk about next steps in this project. So I've cut my hedge back here, and the plan is to have solar panels up against this fence, and I can't install it at this moment. If we have a look here, my neighbour's retaining wall has basically failed, and it's leaning against the fence. So that's outside of my control. And the thing about this, and you can start to see the sun coming out now, this whole fence, including this has got much more consistent sunshine in the afternoon. There's no partial shading to deal with, except for maybe shadows cast by my car in the wintertime. But in the afternoon and the evening time, this fence will be exposed to sun, which is up here in the evening time. And that will mean that we should be able to get some good output from this solar wall, even in mid to late winter time, early February time onwards until early November. That's going to be a welcome addition to the energy production. And there's going to be 10 solar panels, and those are just here, and they've been there for the last 6 weeks now. Once I know what the facts are in relation to this retaining wall and what my neighbours are going to do about it, then we can do some more things. But until then, it has to wait, unfortunately. But one thing I want to just talk about is the maximum MPPT voltage. So the maximum open circuit voltage is 500 volts with a SunSync inverter. These solar panels are open circuit maximum at 41 volts. So that means you can get realistically 11 panels in series. I've chosen 10. 11 panels is going to be fine. You need to apply additional temperature coefficients for the coldest time when these are going to be exposed to the sun. So that's the situation as things stand now. So I hope you found this video interesting. Progress is going to be slower from now on, but performance monitoring keeps going on. So I'd like to thank you all for watching, and I'll talk to you again very soon.